also, we have never heard about the rise in atmospheric temperature of European countries. I was in Germany for almost 3 years for my postdoctoral fellowship, except in June. June again the temperature has risen to 17 degrees centigrade. But now I am hearing that there is a heat wave and the temperature has gone up to 42 degrees centigrade in Germany, in UK, so that is one. And then, I have collaborative work with NCP, or National Center for Polar and Ocean Research. So when they complete their scientific cruise and come back, I used to ask them that what is the kind of, the environment you have encountered with. They say that this time we have encountered number of icebergs. So what are these icebergs? These icebergs are basically due to the melting of ice, and then it breaks from the mainland and then floats in the water. So that is one. And then you all know that our Arabian Sea is warming up. Because 10 years back, means, 1 decade back, if you have to just, try to think that, have you ever come across an incidence of cyclone in Arabian Sea? Never. Though both Arabian Sea and Bay of Bengal are in the same latitudinal belt, we have never heard about. But then we ourselves, Goans, have experienced the wrath of cyclone in the month of May 2020. That is almost 10 days we did not have current. Almost many, the trees were uprooted and many things. So that was only the tip of an iceberg. So therefore, now we can see that in the Arabian Sea temperature is warming up. In fact, almost 1.1 degrees centigrade it has been warmed up. Just imagine, Arabian Sea is almost like our stove in the kitchen. And if you heat that, and if you keep, a vessel containing water over that, it keeps on warming, and what will happen? Ultimately, we find that there is no water in the vessel. So same way here, what happens is that when the Arabian Sea gets warmed up, and again let me tell you, there is no political boundary for the atmosphere. If something happens here above the atmosphere above the Arabian Sea, that will have implications in America, that will have implications in Germany, that will have implications in many other places. Okay? So therefore, you can expect number of cyclones in future in our, dear Arabian Sea. Because we were away from Bay of Bengal, so the wrath was not so much, but now we are going to have that. And then cloud bursts. This is another important thing. In fact, last week I was in Cochin. I tell you, when I went to sleep, there was no water at all down. But then overnight there was a rain that I could not even come out of my flat. So it was completely flooded. So there is the case of cloud burst, and then instantaneous flooding, inundation of low-lying areas, and not only low-lying areas, all the city was completely flooded. And you also know what happened in Bangalore 2 days before. Then, that I said. Then vagaries of monsoon and then heat wave. Now to explain this, because you are all from non-science background, I must speak something little about the fundamental, and then we will slowly go ahead. Now, if all that water cycle or the climate, everything is being controlled by solar radiation. Sun is responsible for our water cycle. For example, you have every year we wait for the monsoon. 2nd of June we will have, the rain starts and it goes up to September. And nowadays you find that, in fact, almost 5-6 years back, there was a case where the monsoon was hijacked and then rain started pouring in Middle East. And like what we experience here, there also flooding happened. Because in Middle East, there is no concept of rain at all. So that has happened almost 5 years back. So therefore, the solar radiation, when you say this is responsible for everything happens here. It's like if you want to cook our food, you have to have the stove, you have to, the heat has to be given from the bottom, but here heat has to come from the top. And wherein, if you see the solar radiation, in fact, scientifically we can say it's electromagnetic radiation. It ranges from cosmic ray, gamma ray, X-rays, UV rays, etc., etc. And again, let me tell you, if the rays are small, means shorter the wavelength, more the energy. Like cosmic ray, gamma ray, X-ray, UV, and then visible. So visible is actually longer than the X-ray. So that is why when you break your leg and go to hospital, doctor does X-ray, because that has the high resolving power, not the visible rays. Doctor will never use any instrument which in turn uses visible to understand something. No. So that is the thing. So that means shorter the wavelength, more the energy, more the resolving capability. Okay. So here, whatever happens on the earth, like climate, it's basically due to visible part of electromagnetic spectrum. That visible part is between 400 to 700 nm, that we can see. Our naked eyes could see everything. In fact, how do you know that I am standing here? It's because the visible rays fall on my body, changes its characteristics, and the return signal carries the information to your eyes, and it finally goes to your brain. And then you say that, oh, so-and-so is standing here. So that is what, so all that what we know here is due to reflected radiation of the visible part of electromagnetic spectrum. And that visible part is responsible for the climate. So therefore, when that visible rays come down, that is being absorbed by the land. You know, there are hot spot and the cold spot, cloud absorbs. And then again, you can say that, the plants, of course, plants want photosynthetically available radiation. A visible part of electromagnetic spectrum is responsible for all the cooking in the leaf of the plant. So all that is required. And then what happens is that because sunlight is absorbed unevenly, we have the currents, we have the wind, we have the deep ocean currents, we have the water cycle, we have, in fact, monsoon itself is due to the heating of the land, and I would say the differential heating of the land and the Arabian, because you have the land here, Indian subcontinent, and you have Arabian Sea here. So the land's basic characteristics, in physics, if I say that, the heat conductivity is very high compared to that of the ocean, because ocean absorbs everything and store in that, and that's being released slowly, and then we get the monsoon. Okay, that's a natural phenomena. So then Now, if you look at the preliminary stages of Earth, when it was formed 4.3 billion years ago, everything was just set right, in the sense that it had enough water vapor, because water vapor is the natural greenhouse gas. You know, you all have heard about greenhouse gas, definitely, I'm sure. Because you have the water vapor, and that water vapor allows incoming solar radiation, and when the radiation goes from the earth, because every object in the universe emits energy. So if you look at the globe, earth as a whole, its absolute temperature is 17 degrees centigrade. Or you can say that 290 Kelvin. Okay, so that also emits energy. So the greenhouse says that all that radiations that are supposed to go to space have been, absorbed by the water vapor. That's why we feel hot. We say that without knowing any science, we say that it's too much humidity, therefore we are feeling so warm. This is the reason, because the back radiation from the earth is supposed to go to, the space that's being absorbed. So therefore, everything was fine, and you see this water vapor makes up to 65% of GHG, and had that not been there, suppose the water vapor was not there in the atmosphere, the temperature would have been minus 18 degrees centigrade. None of us would have lived on this earth. Okay, so therefore, that's a naturally produced greenhouse gas. So then comes the enhanced greenhouse effect, wherein, if you see, the carbon dioxide concentration has been increased to a drastic extent. At this juncture, I think I should mention also some little history about, our economic development. Like if you start looking between 16th century to 1950, or 350 years where we were ruled by British, when they landed here in the form of doing some business with us, that East India Company, 16th century, we had 30% to the GDP. We were the highest. We were offering a lot, 30% to world GDP. But by the time they left in 1947, we were 2%. That means they made us very poor. And moreover, they were also thinking that, we won't be able to sustain like a good country, and rather it will all separate out and all that kind of a thing. But what are, the leaders of then era, they started with the agriculture economy. So we had agriculture economy, that was there for some time. And then we also tried to adopt, or we also tried to, install the industrial revolution, which we could not catch up. So during the industrial revolution, without looking at the sustainability part, we started doing that, and as a result, carbon dioxide concentration has been increased. That's what is written here, that dramatically since the industrial revolution, and therefore now we are saying that we want to have a carbon neutral. we want to have a carbon neutral, and therefore we say that electronic car has to be used, this has to be used, you have to have this, all those kind of things. Because these are all due to the greenhouse effect, especially the carbon dioxide emission to the atmosphere during that industrial revolution. Then, if I look at different gases and also global warming potential, that means which gas has what potential to heat the atmosphere. So that if you see, water vapor, of course, is a natural, greenhouse gas. Carbon dioxide, 1 unit you can say. Then the methane, 23 unit. And then nitrous oxide, it's around 298. Details are written there on the extreme right. And then you see chlorofluorocarbons, 3000. So we could actually control that, because by realizing the fact that this chlorofluorocarbon is going to kill us, actually, there was a Montreal Protocol, and on that basis, many countries have taken initiatives, and then chlorofluorocarbon is under control. So therefore, this is the famous Keeling curve. That is, if you look at from 1960, yeah. Here. Unbutton? Yeah, you can. So if you look at this, this is the famous Keeling curve, which says that from 1960 onwards, how the carbon dioxide has been increased. I have the data only up to 2010, so it clearly shows that how the carbon dioxide concentration has been increased, and this has added, or this has contributed lots to our global warming. Therefore, now today's topic is not on gas, rather on particles. So there are lots of studies have been done on the gases, and there is a lot of difference between gaseous constituents and the particle, because gaseous constituents are uniformly mixed, that is gas. But in the case of a particle, they are heterogeneously. For example, if you have a factory and if you have not taken care of the sustainability, then in that region you will have high concentration of particles, and somewhere else it will be different. That means in the case of a particle, what we experience is that large spatial heterogeneity. So if you look at this, greenhouse gases are methane, nitrous oxide, water vapor, and carbon dioxide. And the aerosols are dust, sea salt, sulfate, black carbon, and organic matter. So these are the distinction. Now, this is something I thought this also I should, because I'm going to address the non-science people, I should also show this. This is about Ahmedabad, what is happening there. Cities dusty air gets deadlier, and this is about Panjim. Vasco, Panaji, Margo, and Mapsa, worst polluter, and this is in 2020. I don't have anything recent one. So this is another important thing. And now, as a scientist, I must introduce something like albedo. Albedo means it's a reflectivity. Okay. I will, before explaining that, I will explain this. See, what is shown here is that if you see the top of the atmosphere, okay, if you see that 100% of solar radiation is coming down, when it comes down, when it interacts with the atmosphere, lithosphere, hydrosphere, then biosphere, and then the cryosphere. Cryosphere is the ice sphere. Like you have Arctic, Antarctic, and then the Himalayan region. All together, 30% of light should go back. Then only we would be able to have a comfortable life on the earth. If due to man-made activity, or if it is due to anthropogenic activity, if something else is introduced, then that balancing act will go. So that means the albedo has to be 30%. This one, 30% of albedo has to be there. So that's what I mentioned about albedo. Albedo is nothing but reflectiveness of a surface. Surfaces with a high albedo reflect more incoming solar radiation. For example, Antarctic and Arctic, the albedo of ice is 80%. That means if 100% of 100 units of solar radiation comes down, 80 goes back. But in case of water, 96 absorbed, 4 goes back. So just imagine that had all the ice been melted, Arctic and Antarctic, then 96% of the radiation will be absorbed. That means our tropical climate would be extended to polar climate. That means we will have the same pandemic which we have experienced here also in the polar region. Okay? So this is a small, albedo means this ratio between energy leaving the surface and incident energy, etc. All right. Now I have to introduce you something, very important aspect. If you look at this is the Earth surface to top of the atmosphere, around 520 kilometers if you see, and what is shown here is the temperature. Okay? So this is called a troposphere. We are all living in the troposphere. That's around 12 to 15 kilometers. So 12 to 15 kilometers is the sphere where you have the cyclone, where you have the rain, where you have the cloud, you have the wind, etc., everything. So this is the troposphere. Okay? And then you have the stratosphere. And if you see here, temperature decreases with the height here. That's why when you travel in a flight around 8 kilometers, the pilot says that now the outside temperature is around minus 40 degrees centigrade at 8 kilometers. So the temperature decreases drastically from here, and then there is a constant temperature, and then it increases. And the stratosphere, you have something called the ozone molecules. And these ozone molecules absorbs all the UV radiation coming from the sun, and thus protecting us from deleterious effect of those UV radiations. But in the event of this particle, due to your own activity, aerosol particles cross this and goes over there, what will happen is that its residence time, that means how long it is going to reside in the stratosphere, it's going to be thousands of years, so that it will be a catastrophe if that happens. And this is something which I thought I would explain, to explain in a very simple way. This is, the energy can be transferred by means of radiation, convection and conduction. When you heat, whatever vapor comes is nothing but the convection, and this is the radiation, and when you touch on a hot body, that is the conduction. Now, I have understood this. Those students who are sitting here, I used to get some complaints from here saying that my students do not have the proper idea of doing research, etc. What is research? Now, I have understood this. Now, how to conceptualize this? You have to conceptualize. I got the idea that if I have more particles, I told you that visible rays are responsible for the climatic variability. Suppose in the event of adding more and more particles to the atmosphere in the troposphere, which I showed you now, what will happen is that most of the particles will scatter the radiation and it goes back because visible radiation. But there are also particles which absorb. So I will show you, this is an animation picture. Yeah, here what happens is that I have particles. This is the top of the atmosphere, and my the troposphere is here around 10 kilometers. Suppose by means of human activity, number of particles are added to the atmosphere. We have dust storm. We also have the land use pattern, like we have number of floods coming in different areas. Due to that, you are actually disturbing the land, and then that also dust can come out. So when you have more and more dust particles over here, what happens is that the solar radiation coming down gets scattered and goes back. So we are living here, it's a cooling effect. But in the event of the atmosphere having both the when you have a particle which absorbs the radiation, which are these particles? These particles are, I'll just give an example, these particles are those which are coming out when you fire the residue of paddy in Punjab and Haryana. In November, December, we have heard that there's a lot of atmospheric pollution in Delhi, and most of the people have breathing related problem, lungs related problem, etc. Because this is the reason is that during winter, this troposphere is very down. You also have something called planetary boundary layer. Okay, that's hardly 1 kilometer. That will be overnight, Earth is cooling. So this is just going down, and all that particle here are being trapped over there. So in the morning, you are going for a morning walk through this highly polluted air, and then you breathe that, your lungs and all that will be trapped. So that is what, if you have particles which are called soot particles, and these soot particles are basically due to firing of this residue of paddy. That adds, and then and that also has additional effect of absorbing solar radiation. So if you have more soot particle, scientifically we call that as black carbon, BC, black carbon. So that is actually next to carbon dioxide, because carbon dioxide also absorbs solar radiation. This also absorbs solar radiation. But the difference between carbon dioxide and this is that carbon dioxide is uniformly mixed. These are heterogeneous wherever it's produced. So therefore here you have the warming. Then you have the radiation coming from the Earth's surface, because back radiation, and re-emitted to the, so you have again warming here. That means if you have this kind of a particle, what happens is that it not only absorbs the solar radiation coming from the top, means solar sun, and also the radiation emitting from the Earth's surface. So that means it will, the temperature will be multiplied when you have this kind of a particle. This is an example. Like there was a fire event at Taligav Plateau, a waste dumping yard, and then you can see that this happened on the 2nd of April 2021, I think, yeah. You can see that around 1630, it's around 5,000 nanograms per meter cube. So in 1 meter cube of the air, 5,000 nanograms of particles are added because of that fire event. And then it sustains, and you can see that early in the morning, early in the morning, you can see again it has been. That means it's actually not added, rather this is like a lid. That planetary boundary layer is like a lid that goes down during night time. So it traps everything there. So early in the morning when you go for any of the activity, this is what you will be breathing. So this is a typical example of what happened when you have a fire event. And if it is a forest fire, just imagine that what type of or how many concentration would be added to the atmosphere. You can say that even though the fire persisted, low values of BC were seen around 2100 hours. As the winds from Dambiar, I have also tracked that. You can see that from here it has gone to Arabian Sea, because the wind direction was not towards university, Goa University side. Had it been that university, we would have all that the particle in the university itself, and definitely many of us would have been definitely in the hospital, because the 5,000 to 6,000 nanograms per meter cube was added to the atmosphere. Now let me brief you what are these aerosols. These are minute particles suspended in the atmosphere. They scatter and absorb sunlight and can be emitted directly, primary or created through chemistry, second, and act as a site for chemical reaction to take place. So these are the you can just see this. These are the activities. Through this you can expect the addition of aerosol or the particle to the atmosphere. And remember that these aerosols are two types. One is scattering type, another is absorbing type. Scattering means solar radiations are scattered back, therefore you will have a cooling effect, and if you have absorbing type, it will warm. This is actually very when I came to know about this news, I was really taken aback, because this 16.5 to 18.5 kilometer means it's in the stratosphere. So the ISRO and NASA together have done a study wherein they find that between 16.5 to 18.5 kilometer contains particle of size less than 0.25 and around 90% are volatile. So imagine that stratosphere is a stable layer. If this goes there, then as I said earlier, the residence time will be thousands of years. You cannot remove that, because rain etc. is happening in the troposphere. So that is something very, very serious, and then this is the report of combined study by NASA and ISRO. Now types of aerosols are dust, sea salt, sulfate, black carbon. This black carbon is the one which is coming out as a result of biomass burning and fossil fuel burning. Fossil fuel means your the vehicular emissions that creates a lot of black carbon there, and this is the black carbon, this is volcanic ash, this is sea salt. And small particles or droplets suspended in the atmosphere, important both for daytime as well as climate change. You can see that this is volcanic ash, pollen, sea salt and soot. So these are the different type of aerosols one could encounter within the atmosphere. Now changes in formation, see, this is very important. What happens is that even if BC, I said about BC particle, that is the soot particle. Soot particles have the inherent characteristics of absorbing solar radiation, but then if it is there in a humid environment for a long time, it camouflages itself in the sense that it will have an outer space, and then thus it attracts water vapor, and in turn it acts as a cloud condensation nuclei. So therefore, inside the cloud you can expect this BC. But when the radiation, when the solar radiation falls on that, slowly inside the cloud you have BC, that slowly absorb that and then disseminate the cloud, so that you won't have any rain at all. And on the other way around, if you have the particle which are not BC, other particles, that can act as a cloud condensation nuclei, and that gives you the cooling effect over here. So changes in reflectivity, some aerosol can alter the properties of cloud and changing the reflectivity of lifetime, etc., and can inhibit or enhance cloud formation. Now, where does it come from? It is from dust, deserts, and also from agriculture. Sea salt, that is from oceans. Sulfate aerosol you have, that is chemical reaction of sulfur dioxide, volcanoes, fossil fuel burning, and marine plankton. In fact, if you know, 71% of the earth is covered by ocean, and you have, similar to plants we have on land, there are plants in the ocean. So that plant are the marine plankton, and that emits something called DMS, dimethyl sulfate, and this dimethyl sulfate, undergo chemical reaction in the atmosphere, and it becomes sulfate aerosol, and that in turn acts as a cloud condensation nuclei. So that means if you have more marine phytoplankton, what happens is that you can expect more cloud, and then you can say that phytoplankton is actually helping our water cycle. Okay. Then volcanic ash, this also is responsible for this. You can see this here. In fact, in UP, Bihar, I hope there is nobody sitting here from UP or Bihar, but it's all 10 years back I am saying, not now. UP, Bihar, etc., people were using firewood for cooking, and if you all remember that after this central government of, the Prime Minister Modi has taken over as the Prime Minister, there was a request to all of us that those who are having more than one cylinder, please surrender 2 cylinders, because so that they can be given, so that this emission to the atmosphere can be reduced. So that is the research. That means whatever research we do, it is not just for the sake of research. Rather, that would finally go as the policy for the government. So the research output, and therefore we say that you have to publish your data in an international journal, because that will have a quality data, and that will go as the policy. Because I have got, so far I have got around 6 crore, now I got another 1 crore also, though I am the Vice Chancellor, I got 1 crore. Money is not given just for doing research, rather it will come out as an output, and that would be helpful for the government to future policy making related aspect. So this is something, this is the reason why the government of India has asked us to surrender 2 cylinders, because I used to have 3 cylinders, so I surrendered that 2 cylinder, because I knew that this is what is going on. And organic matter, biomass burning, fossil fuel burning, and also you see nowadays we have electric car. This is the reason. Fossil fuel burning, because, and again, I don't think that any one of us have the diesel car, because diesel car emit more to the atmosphere. So therefore we don't go for diesel car, rather we use only petrol car, right? And nowadays the electric car, and again we say that if you buy an electric car, 3 lakh you will get from government. This is what? This is the reason, because by that way we can actually control the global warming by reducing the emission of aerosol to the atmosphere. Then chemical reaction of ammonia and sulfate, etc. BOC. This is, see, you can see this is very, very interesting. This is actually from the satellite. When initially I started working on instruments available, means in situ instrument, which we say instrument means we go to the area of interest and we started taking the measurement. But then I realized that I want to have a bird's eye view. So to have a bird's eye view, I cannot afford to have only this in situ instrument. Therefore, I have to depend on satellite. So therefore, the satellite data have been processed. You see that from where to where the dust is going. All this Saharan dust from here, it's going to American coast. And there are number of cases where lot of fish killing is there in this side. And economy of America has been especially the the export in terms of fish, etc. There are some studies were there, and this is what happens between African continent and American continent. So you can see that, and this color is 1.5 means AOD, aerosol optical depth. So this is high values of particles are there. The color shows this is less and this is high, very high and very less values. Yeah, see, this is very important. Humans contribute to land conversion. This is what is happening, I don't say in Goa, but somewhere else, like we convert the paddy field, we convert many to build flats, and then we also divert the rivers, etc. And then as a result, what will happen is that albedo is approximately 0.5. Albedo means, I said, reflectivity. That means if albedo is 1 means all 100% is going back. 100 by 100 is 1. Right? 0.5 means 50% is absorbed. Why? Because of human activity. That is what it says. So therefore I asked that, does dust cause cooling or warming? Both. It is over forest or water. If it is over forest or water, then the cooling. Sand is lighter than the forest or water, therefore it's cooling. But if it is ice or snow, what happens is sand is darker, lower albedo, therefore it absorbs, and that in turn augments the melting of ice if it falls to ice. This is basically sea salt, of course. This is the region where you have very high value, 100% you have the salt concentration, and mainly from oceans, and then solid particle animals hydrated with water. Mostly these are all salt, of course, is natural, not man-made, and then this causes cooling. If you have salt particle, that gives a cooling effect only. And then sulfate, that is nitrates, are similar secondary emission. Sulfur dioxide, this is basically this is anthropogenic and DMS, as I said earlier, from phytoplankton. That is naturally produced, and this is human interaction. Here albedo is 0.99. In case of mostly fossil fuel combustion, albedo of 0.99. Does this cause warming or cooling? This is all over the world. What is happening? We have done it. It's SO2 from anthropogenic sources in 2000. And then black carbon. See, all over the world, what is the black carbon? And mostly biomass burning and fossil fuel combustion. Fossil fuel is from the cars. Appears black to the naked eye. What would be the albedo? 0. That means nothing is going back. All that radiation coming down would be completely absorbed. Does this cause warming or cooling? Definitely warming, no cooling, because nothing is going back. Then mostly from, you can see that black carbon emissions. See, China and India again were northeastern region. There you have high BC. This BC is due to, one is biomass burning. That is why the government has come out with the appeal for the cylinder. Second is that residue of the paddy, that. And this one, this is due to diesel, because the Chinese electricity is basically diesel oriented. So that is why domestic coal burning is there in China. And here in Europe, this is again from the cars and the four-wheelers. You see America, there is nothing, very, very little. See, it's only 0.07. It's basically Africa and this region, India and then China. These are the regions contributing BC to the atmosphere. That's the reason why there is a hue and cry by when Trump was the president. He said that, no, we have to have a meeting, we have to reduce. But then our Prime Minister said that we are a developing nation, you have already developed. So let us also develop, and we will see that an optimum level is taken care. That is done, and then it went ahead. This is organic matter from phytoplankton and from the trees, etc. And the fossil fuel and See, where does it come from? In fact, high concentration due to land clearing and agriculture fires. This from South America during July to September, and Central America during March to May. Central and South Africa, it is from June to September. Southeast Asia, January to April. But if you see the Arabian Peninsula, May to August. And high concentration due to human produced air pollution, North India and Himalayan region. Just see that it's a very alarming rate, because if you produce the BC in this rate, definitely you can expect the ice in Himalayan region melting, because that is the cryosphere which I said earlier, Himalaya, Arctic and Antarctica together, and then the lithosphere, land, then water, then atmosphere. Everything together 30% should go back. We should not disturb anything. If you disturb that, then you will be like an oven, and then you will be, you will be heating your food for using oven, same kind of a feeling you will have. And then Eastern China, you see, most of the year they do. And this is actually very, very interesting. If you can just click this, if it is connected to internet, can you just click this? This is, you can see that, this is a video, you can see that how the aerosols are being transported from here. Yeah, it will come. Wi-Fi is not connected. Okay, if it's not there, fine, you go back. Otherwise, you would have seen that how, see, it's like, I made a statement that atmosphere doesn't have any political boundary. This is exactly what you can see here, because what all happened in Africa or any other region, slowly transport to this. Yeah, okay. Yeah, so this pale yellow is clear sky. This is all clear sky and maximum visibility, and then dark red brown, very hazy condition, this one. And this moves, you can see that monthly variability. Last 20 years of data is there. So how that moves from this region to that. And also you can see in Indian subcontinent which month you have high AOD. That also you can see here. Then this is PM 2.5 concentration. You can see where India stands and where China stands. PM 2.5. There is a continuous measurement of PM 2.5 because PM 2.5 is an important aspect as far as our health is concerned. If PM 2.5 goes up, it directly goes to your lungs, and then you will be landing in a hospital. So you can see that here, northeastern part of India, you have it, and then China. And here, these are all very less, 5 to 10. This is micrograms per meter cube. In 1 meter cube volume of air, how much micrograms of particles are there? Health impacts, I just said, fine aerosol particles are responsible for causing the greatest harm to human health. Inhaled deep into lungs, they can cause breathing and respiratory problems. This is what happened in Delhi during November, December, January period. And then also, when you have more and more particles in the atmosphere, the plant needs this energy, 0.4 to 0.7 for their photosynthesis. That will be reduced, and then reduction in productivity and all that. Enhanced mortality, cardiovascular, respiratory and allergic diseases, asthma, bronchitis, cancer, etc., increased lung toxicity, all this. If you have a super fine particle, then it will never go. It sticks to your lungs only. And then it's not that only at the surface you have. So here, this person has done an experiment where he finds that, see somewhere here, around 3.8 kilometers from the surface, from the sea surface, there is a concentration of aerosol. Means aerosol is trapped over there. That is again very important as far as our monsoon is concerned. I am coming to that. And here, this is the equatorial region, where again you can say that smoke and pollution mixes with the shallow cumulus clouds. So please try to understand that those are the actually very, the pristine atmosphere, the ocean, atmosphere over the ocean, Arabian Sea, Bay of Bengal, and of course Southern Ocean, they are all pristine. But then you can see here that smoke and pollution mixes with the shallow cumulus clouds. And therefore, you won't have a clouds over there. See here, this is an experiment performed by us. And this is what our monsoon. This is the process of monsoon. Here, during June, you have, from April onwards, of course, you have the heating. And as a result of heating, here air rises. And there is a depletion of air mass here to compensate that air is coming from Arabian Sea. And by virtue of the fact that the air is over the ocean, it is saturated with water vapor, it rises, produces cloud, and gives us rain. But in between, if you have aerosol, what will happen? Because unless and until the land gets heated, this is risen, we won't have this monsoon. So if the particle comes in between, if this aerosol comes in between, you won't have a good monsoon. Sometimes even there will be a break in monsoon. This is winter, where this is from here, because winter you have high pressure here, and from here to here it's going. So this is what is going on during June to September and subsequent period over India. So this is what I said, monsoon vagaries. And therefore, over 60% of world population live in Asian monsoon regions. Monsoon-related droughts and floods and aerosols are the two most serious environmental hazards in Asian monsoon regions. The monsoon water cycle is driven by atmospheric heating, which I said, etc. Just now, through the dynamical interaction of wind, moisture, clouds, and rainfall, and then, of course, all this aspect, which I just explained. And now, after having explained this, let me just tell you what are the kind of facility we have created at the Goa University on the basis of number of projects. Here, these are the instruments we have. This is a multi-wavelength radiometer that is there at the top of the building, and every day morning around 8 o'clock, one of the research scholar goes there and she adjusts with the solar radiation. Once it is adjusted, it's computer based, so it's connected down. My old room have all the the control center, etc. So that takes care of that. In the morning, if it is looking towards the east, evening it will be looking towards the west. So it only measures the intensity of the light, and through which we derive the aerosol optical depth. That is this. And then we have nephlometer. Nephlometer is, it gives you the scatterance. Do you have more scattering type of aerosol or absorbing type of aerosol? Suppose the albedo goes down, then we are very, my heart started beating up, because what will happen is that you have more and more BC particles. That means more absorption is there if the albedo goes down. That is what nephlometer. And then you have ethylometer. This is basically to understand the concentration of BC. You can estimate the concentration of BC. Then we have quartz crystal microbalance. That is basically to know that what is the size range. It has got from 0.2 to 25 micrometers. And then this is microtop. This we carry on the ship, because we must also know that all that activity over the land has it been affected over the ocean also. I will show the result now. So therefore we have that. And this is microethylometer. What we do is that we have this balloon. Okay. On the balloon we fit this microethylometer. This balloon is almost of this size. This is all going on the ship. So then we connect to this. It's a tethered balloon. So it goes up to 3 kilometers, measure all the BC from the ship towards that, and then comes down. And this is something which I installed in the university campus. This is a 1 crore project from ISRO, and wherein you have all the instruments. All the instruments are there from 32 meters. What is happening in Goa, I would study from this. And this is just, this is the kind of mathematics, because I am basically a mathematician, so this is the kind of mathematics we adopted to understand. Atmosphere is like a box, and then on the top, this, what is the forcing, we estimate. So if I have this kind of a particle, BC particle or scattering type of particle, what is the forcing, how can it impact? So those kind of studies have been carried out by this. And then this is the modeling aspects, and this is the model. Through this model, we estimate many of these parameters. This is also part of that. Now you see, during that breakdown, like your COVID, the lockdown period, you can see that April, the aerosol optical depth has come down to 0.05. See, in January it was 0.7, so a highly turbid atmosphere that has gone down to 0.05 during that lockdown period. I thought this would be of interest to you, therefore I took. And this is a study we have carried out, which shows that intensification of low pressure in Bay of Bengal during that COVID lockdown period, we had an Amphan cyclone in the in Bay of Bengal, but in the east of Sri Lanka. So that we studied, and then this is already published. That we studied, and then it clearly shows that the aerosol optical depth or the aerosol prevailing in the atmosphere has an effect on the cyclone formation. It's actually the coupled effect between the aerosol and the sea. That's what we understood. And this is what, so decrease in aerosol, increase in surface reaching irradiance, therefore warming, and then increase in the OMT, and then all that. This in the university campus also we have done that during the lockdown period, what really happens. See, this is P1, P2, P3, is not clear, P1, P2, P3. This is the lockdown period, you can see how much it decreased. This is 2019, this is 2019, this is 2020, just lockdown. So you can see that how the particles have been decreased during this period. And this is also already published, this is the same thing. And then the radiative forcing. This is the result of the aerosol observatory during December, January. So every month, how the aerosol is changing over, the Goa state. that has been studied, and this is also part of that. And then you see aerosol loading from remote location. See, whether you have mining here or not, you won't be freed from this because it is coming from somewhere else. So see that during January, from which direction aerosol is coming to Goa, and February where it is. And again it is at 500 meter and 1500 meter. That means 500 meter from the surface and 1.5 kilometers from the surface. And these are the different regions from where it's coming. And this is during June. Of course, during June you will have only from ocean. Therefore, this is the water vapor. But otherwise, these are all anthropogenic. And then we have also divided like how much is continental, how much is maritime, how much is West Asia. That also has been done. And then we also have done the Antarctic region, because Antarctica is actually an important aspect as far as the global climate is concerned. So we have done almost 1, 2, 3, 4, 5, 6 cruises we have done. 6 cruises during this period. One was sailing from Goa, another was from Chennai to Chennai, then these two were from Mauritius. So we have gone from there, and this is I'll just show you the lab setup, etc. Because I just want to show the younger generation that research is such an interesting thing, provided you come forward and start working on that. This is the ship, and this is the lab setup, and you can see that these two young research scholars working with me, they have done 2 girl children. I have to say that, not boys. These 2 girls have done it. See, they are launching the balloon, tethered balloon, and then measuring BC in the Antarctic, near to Antarctic side. So that is what. One is Neha, she is Neha, and other is Adiba. Neha and Adiba are doing that work. All the instruments have been set up over there. And these are the particle size in the the Southern Ocean. You can see this is a decadal variability, or last 10 years how the particle has been changed. That has been examined, and this is the solar insulation, and that is chlorophyll. So basically, Southern Ocean, the aerosols are naturally produced. That means along with the sea salt, you also have something from the chlorophyll. See, this is very important. You see here, 50 degrees south, that means almost near Antarctica, you have BC particles around 80 nanograms. These BC particles, its characteristics, you know that it absorbs radiation. Suppose in the event of this, being augmented as year goes, then definitely you can find more and more ice to melt. So this is an important result we got from the study. This is the aerosol radiative forcing, and we have also computed the heating rate. Suppose this is the BC prevailing in the atmosphere, how much is the heating it can generate, and due to this heating, how much ice could be melted. So that also has been studied. This is also decadal variability. And this is monthly chlorophyll, and this is DMS, dimethyl sulfate, and this is cloud particle radius. So what we did is that we tried to understand whether this phytoplankton is responsible for the cloud formation or not. So therefore, that also has been done. Then the cloud albedo we have estimated, and cloud fraction. Yes. Now this is another thing. 50 and 60, between 50 and 60 degrees south, we could see that there is a copper, zinc, and cadmium over ocean atmosphere. Just imagine this. We could see that copper, zinc, and cadmium were in between 50 to 60 degrees south, thousands of kilometers from the continent. So who is responsible for that? And this is again another thing. Yeah. If you try to see from where it comes, this is all coming from this continent. These are the positions from where we have collected the data. These are all coming from there. And finally, this is a model we have developed. I don't think I will explain that because many of you are now getting bored, I think. So I will not. But rather I only say that what we learned. This slide I have just added. Aerosols have done a lot more than just offset the global mean surface temperature due to long-lived greenhouse gases, but also altered regional water cycle and climate in ways that are still not understood or even known. And then climate change hazards in Asia can lead to drought, dust storm, flash flood, melting of high mountain glacier, biomass burning, and tropical cyclone. So for all these things, we are responsible. Therefore, we have to see, this is another very important thing. About 40% of the glacial retreat is because of black carbon impact. And 75% of Himalayan glaciers that are home to 11,480 million people are shrinking at an average rate of 3.75 kilometers in 15 years. This has been studied through satellite data. Okay? And black carbon affects precipitation, means the rain, and is a major factor in triggering extreme weather in eastern India. And what we have seen even in the heat wave in Europe, etc., this is one of the important factors. And Bangladesh, where the cyclones, hurricanes, and flooding are common. Okay? So that's all from my side. If you have any questions, please. So in short, what I want to tell you is that if I take you back to the second slide, I mean the European countries are getting warmed up, Arabian Sea is warming up, etc. This is one of the reasons. There are many other factors, but this is one of the reasons. But if you take care, I have seen many, houses, the plastic, but nowadays it's not, but at least the paper and other things are just burned in the backyard of the house. Don't do that, because you may feel that by doing that it's only very small amount, but integral effect of that. When thousands of people do that, what happens that will certainly affect the climatic condition over there, water cycle over there. So that's the reason why I have specifically taken this topic. Hope at least 10% you have understood. If you have understood 10%, I am happy, because I always believe that the foundation should be strong. That 10% is your foundation. Then now you can build on that. Thank you.
Thank.
They are good teachers.
Yeah.
They can spread the word better.
Exactly. Because this is something which we need to take care of. Burning of the biomass or anything. You say that you have dry leaf in the backyard. What you do is that you broom it and then burn that. Don't do that. Now for the residue of the paddy. Now government has come out with a plan wherein they will not burn that. Rather, there is a chemical reaction is being done. But when you do that chemical reaction, that may even affect the soil. That's another important thing. So that also needs to be taken care of. So it's different aspects, because once bitten, you will be very careful. There is a saying in Malayalam, Anacha vellathil veena poocha, pacha vellangal. Means if a cat falls into hot water, even if it is cold water, it will not go to that. That is the kind of the feeling we have across the world, so that everybody is taking care of that. Thank you so much for giving me this opportunity.
Sir, thank you so much. We could see Vice Chancellor being a teacher over here, and such a beautiful lecture, informative lecture he's given us. I'm sure there are many questions which are there in the mind of the students and the teachers also, but because of the paucity of time, we are not taking the questions.
No, but you can take one or two questions, no?
Sir is saying one or two questions we can take, if anybody is interested in asking. Can we provide with the cordless mic?
Cordless phone. Huh? He's from?
Sunil Kumar is associate professor at the college and is asking a question.
Thank you. First of all, I would like to convey my gratitude, sir, actually, for delivering a wonderful lecture. I was really enjoying throughout the time.
Thank you.
Being a geography teacher, I have understood at least 50% of the things, sir.
Thank you.
Only one thing, sir, actually, as aerosols are produced because of three actions. Man-made actions are there. Dust, which are just blowing from different parts, actually, that high pressure to low pressure to high pressure. And natural, sir. You have highlighted very nicely about all the man-made activities responsible for producing that all aerosol. But what about that, sir, natural? Because there are many activities done by the nature cause actually producing these particles, sir, and very dangerous.
Exactly. See, for example, the fact that we have deserts in Rajasthan and all those, it's there.
Okay, sir.
All this reason is that you have lots of dust added to atmosphere.
Right.
And when initially, if you remember, I said that 43% of the radiation, visible radiation, that is responsible for climate change.
Yes, sir.
So those radiations are interacting with this dust particle, gets reflected and goes back. But again, let me tell you, dust particle, the chemical composition is going to be different. If the chemical composition is such that it has the absorbing character, then it also will be very dangerous.
Very dangerous.
That is the reason why you have deserts in those regions, because there is no rain over there.
That's right.
Rain to happen, you have to have heating of the land, and then air has to rise. That has to be replaced by air coming from the ocean.
So are we in position to check and control that all these natural actions, sir?
Natural activity you can't. But again, let me tell you, you are, for example, land use pattern. You take care of the land use pattern, have an EIA analysis, environmental impact assessment.
Yes, sir.
And then go for a flat construction or a building construction, etc., etc. Otherwise, what will happen is that you are doing this, that adds towards the nature also.
Yes, sir.
So you are actually augmenting the natural process by your action. So that is there.
Thank you very much.
Yeah.
Anyone else would like to ask a question then?
Okay.
Thank you very much, sir. We can see the knowledge is there with sir. He just wants to share it with us. I'm sure maybe another time sir will come to our college and share his knowledge. Thank you so much for such lovely lectures and so much of knowledge you have given us. Thank you very much. Dev bare karu. Time has come to appreciate the efforts put in by our students for last 2 years in their all-round development. On behalf of Goa Vidya Prasarak Mandals, Dr. Dada Vaidya College of Education, we would like to felicitate the students who have done extremely well in academics and other co-curricular activities. In our college, some of the scholarships have been sponsored by our ex-principal, Dr. Alan Abrio. As I take the names of the scholarship and the name of the students, please come forward and accept this felicitation from the college, which will be presented to you by Honorable Vice Chancellor of Goa University. May I request sir to kindly do the honors. Scholarship for the academic year 2021-2022. Late Mr. James Abrio's scholarship for the students securing the first place in the college at the university B.Ed examination for the academic year 2021-22 is awarded to Ms. Sheikh Ashiba Aisha B. Late Mr. Victor Desa Coelho Scholarship for the students securing second place in the college at the University B.Ed examination for academic year 2021-22 is awarded to Ms. Naik Madgaonkar Bhakti Dilip. Can I request the students to come forward fast? Late Mr. Victor Desa Coelho Scholarship for the students securing second place in the college at the University B.Ed examination for the academic year 2021-22 is awarded to Ms. Somnavar Bharti Basappa. Second place have been shared by 2 students this year. Late Mrs. Maria Abrio Scholarship for the students securing third place in the college at the university examination for academic year 2021-22 is awarded to Ms. Vaingankar Santoshi Shravan. Santoshi hasn't come. In her absence, her guardian is accepting the scholarship and the certificate. Can we have loud round of applause for our students for doing so well in the B.Ed examination? Late Mrs. Maria Teresa Coelho Scholarship for Best All-Round Student, both in curricular and co-curricular activities for the academic year 2021-22 is awarded to Ms. Sheikh Aisha B. All-Round Student and standing first in the college for B.Ed examination for the year 2021-2022. Congratulations to all the B.Ed students for bringing the laurels to our college and with the flying colors, passing with the flying colors. We also encourage our students to do very well in English language. So, late Shri G.R. Vaze Scholarships, the founder president of All Goa English Teachers Forum for English Language Teaching, the scholarship for the academic year 2021-2022. Late Shri G.R. Vaze Scholarship for the students securing highest marks in English in the college at the University B.Ed examination for the year 2021-2022 is awarded to Ms. Prabhu Hamre Simoni Sukesh. Late Shri G.R. Vaze Scholarship for the students securing second highest marks in English in the college at the University B.Ed examination for the year 2021-22 is awarded to Ms. Gaude Ankita Madhu. Late Shri G.R. Vaze Scholarship for the students securing third highest marks in English in the college at the University examination for the year 2021-22 is awarded to Ms. Chavan Aarti Ratnakar. On behalf of Aarti, her cousin will be accepting the felicitation and the certification. Late Shri G.R. Vaze Scholarship for the students securing third highest marks in English in the college at the University B.Ed examination for the academic year 2021-22 is awarded to Ms. Rodriguez Valency Presi. I think we should give a round of applause to these students for bringing the laurels to our college and doing very well in the subject English. As we said, we also have Masters in Education and our students have done very well in the examination. Late Shri G.R. Vaze Scholarship for the students securing first place in the college at the University Masters in Education examination for the academic year 2021-22 is awarded to Ms. Nagarchi Lubnaz. Second rank for M.Ed program was secured by D'Souza Savia Maria Magdalene. May I request her to please accept this certificate. And the third rank at the M.Ed program goes to D'Souza Elchi. Diploma in Pre-Primary Teacher Education. We also felicitate the students of Pre-Primary Teacher Education course. Late Shri G.R. Vaze Scholarship for the students securing first place in the college at the University Diploma in Pre-Primary Teacher Education examination for the year 2021-2022 is awarded to Ms. Veena Anisha Kalpur, but she is not there. In her absentia, her friend will accept the certificate and the scholarship. She has sent a note saying that she is very thankful to all the teachers of the college for giving her the opportunity for being a good student. The second place goes to MC Emily Bosco at Pre-Primary Teacher Education course. The third rank has been secured by Pujari Regina Ayappa at Pre-Primary Teacher Education course. It's a great honor to inform the audience that SCRT Goa conducted Goa Teacher Eligibility Test and college facilitated, guided the students with orientation cum coaching program in 2021, which was coordinated by Shri Vinayak Morya, Assistant Professor at the college. This year, we have students who have done very well at GTET. We would like to felicitate them. The first rank goes to Ms. Siddhi Khandeparkar, who secured first place in the paper and is eligible to be teacher for class 1st to 5th standard. I think I should request President GVM's General Body, Sir Khandeparkar, to accept this certificate on behalf of Siddhi. I would like to mention that Siddhi is daughter of our President Shri Khandeparkar. The second, Ms. Shefali Darvi stood first in batch paper 2nd, eligibility to be teacher for class 6 to 8 in social science. Shefali Darvi did very well at GTET examination. Ms. Dias Dale Antonio stood first in the batch paper 2nd, eligible to be teacher at the class 6 to 8 in science and maths. Sorry, Mr. Dias Dale Antonio. I think we should give a round of applause to all the students for doing very well and wishing you all the best. Thank you so much. It is said that precious gifts for our beloved ones are trust, honesty, love and care. Today we would like to present these gifts to our chief guest, Honorable Vice Chancellor of Goa University, Professor Harilal Menon, in the form of portrait of Dr. Dada Vaidya. May I request Chairman Sir Shri Krishna Shetty to do the honors. I would request all the students who have accepted the felicitation to wait for the group photograph. May I now request Shri Sanjay Govekar, Associate Professor at the college, to propose vote of thanks.
Thank you, ma'am. Good evening, one and all. As all things, good things come to an end, so is this beautiful program. On behalf of GVM's Dr. Dada Vaidya College of Education, myself, Sanjay Govekar, Associate Professor at this college, take this opportunity to propose a vote of thanks to those who have directly and indirectly contributed to have and help us in making this program such a resounding success. For 2021, we have initiated Dr. Dada Vaidya Memorial Lecture Series and have put in sincere efforts to make it a grand success. Coupling it with the felicitation of the meritorious students, this program reminds us, and as Sir has said, this program reminds us and educates the new would-be teachers about the contribution made by Dr. Dada Vaidya and his colleagues to the field of education, literature, health, industry, social work, and various other different fields. So, let me thank this great visionary for having envisioned of uplifting the standard of the common people by motivating them to educate their children. I'm very sure it would have been a Herculean task to convince the parents then to send the children to school, especially during the Portuguese era. At the outset, I would like to thank our respected and most distinguished chief guest and keynote speaker, Honorable Vice Chancellor of Goa University, Professor Harilal Menon. We are really enlightened by your knowledge and presence, sir. You have touched upon the topic which every citizen needs to know. bearing its technicality, I must say, you have done so well that everybody present here could easily grasp it. You made our day, sir. Especially we have learned so many things, aerosols, the effects of it, albedo, there are so many things, and why, what is our responsibilities now? As sir said, 10%, we have understood more than 20%, and we would be acting upon it that also, sir. Thank you, sir. Thank you very much. And in Malayalam, they say, I think, Nanni. Thank you, sir. We are thankful to Honorable President of GVM's General Body, Shri Bhaskar Khandeparkar, for his consistent motivation and backing, sir. In fact, celebration of this day on a grand scale was suggested by Khandeparkar, sir. And now it has become the most important program of this college. Thank you, sir. We are thankful to Honorable Chairman of GVM's Working Committee, Sri Krishna Shetty, sir, for his continuous support and guidance. Sir has ensured that despite of his busy schedule, he makes time to grace us with his presence and for all the events and functions that we invite him for. Thank you, sir. Thank you very much. Let me thank the Secretary of GVM's Working Committee, Sri Jain Bandurkar, sir, for his presence over here. Principal of Kare College of Law, Sir Sabati Silva, and his colleague. We are thankful to all the members of Goa Vidyaparak Mandal, heads of the different schools, higher secondaries and schools, then colleges, PTA members, heads of the institutions with whom we have signed the MOUs, members from the principal forums, ex-principals of the college, ex-principal of the college, Dr. Alan Abreu, and all the felicities here who have received the honor from our chief guest, and all the dignitaries in this August gathering. Let me also thank the reporters and cameramen of the electronic media and the print media who have covered the entire program also. I would like to take this opportunity to place on record our hearty thanks to our principal, Dr. Jojen Matthew, for his perfect logistic support and guidance and searching for the best resource person for this program. And Dr. Jojen Matthew is so skillful that he has ensured that all the arrangements are done, from designing the invitation cards, sending it to the dignitaries, planning, and to the systematic execution of it. A special thanks to the students who have sang a melodious welcome song here, the lyrics of which was written by Dr. Hanuman Choprekar. Entire organizing committee, coordinator of the program, Ma'am Karuna Satardekar, teaching staff, office staff, multitasking staff for their persistent support and coordination. A heartfelt thanks to all the students for active participation and involvement. With these warm words and kind message, we move to the end of today's program. Thank you very much. Jai Hind, Jai Bharat. Now may I request everyone to rise for the national anthem. And requesting Harsha and company.
जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंधु गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभाशिष मागे गाहे तव जय गाथा जनगण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे.
Refreshment has been served, requesting all the staff and the meritorious students to kindly gather here for group photograph. Sir, we'll have one